In the previous video, we studied about the Galilean transformation for the coordinates. That means you have two frames. First frame is S, which is at rest, and the second frame is S prime, which is moving with a velocity v with respect to the first frame S. So the coordinates of the first frame is given as x, y, and z, whereas the coordinates of the frame which is moving with a velocity v with respect to the first frame is given as x prime, y prime, and z prime. In Galilean transformation, we have studied that these two sets of coordinates are connected through Galilean transformation. That is, x prime is equal to x minus vt, y prime is equal to y, z prime is equal to z, and t prime is equal to t. So these are the four equations that stands for the Galilean coordinate transformation we discussed in the previous video. Next, we are going to talk about the Galilean velocity transformation. That is the transformation of the velocities when we move from the rest frame to a moving frame, which is moving with a velocity v. So these are the distance or the coordinate axis. Now, in order to get velocity from coordinates, what we have to do is to take the derivative of the coordinates with respect to time. അതായത് നമുക്ക് coordinates ഉണ്ട്, x, y, z ഒക്കെ ഉണ്ട്. അപ്പം to find the velocity along x-axis, you have to take the derivative of this equation with respect to time, and to find the velocity along y-axis, you have to take derivative of this equation with respect to the time t. So in this frame, you have to take derivative with respect to t prime, and in the s frame, you have to take derivative with respect to t. But since t prime is equal to t, the derivative d by dt prime is also equal to d by dt. Now, we are moving to the velocity transformation equations. Velocity transformation. Consider the first equation, x prime is equal to x minus vt. Taking derivative with respect to time on both sides, we have d by dt prime of x prime is equal to d by dt of x minus vt. This prime stands for the s prime frame, and unprimed t stands for the first frame. So d by dt prime of x prime is equal to d by dt of x minus vt. Now, since dt prime is equal to dt, we can write this as dx prime divided by dt is equal to, now taking derivative of each equation, dx, now taking derivative of each terms separately, d by dt of x minus d by dt of velocity into time vt. We know that the second frame s prime is moving with a constant velocity v. That means this v is a constant. ഒന്നെങ്കിൽ 10 meter per second, 10 kilometer per hour, അങ്ങനെ ഒരു കോൺസ്റ്റന്റ് വാല്യൂ ആയിരിക്കും നമ്മുടെ വിക്ക് ഉണ്ടാവുക. അപ്പോൾ വി എന്ന് പറയുന്നതിന് നമ്മളൊരു കോൺസ്റ്റന്റ് ആക്കിയാണ് ത്രൂ ഔട്ട് കൺസിഡർ ചെയ്യുന്നത്. Now, dx prime by dt prime is the velocity of the particle along the x direction as observed from the s prime frame. നമ്മൾ s prime ഫ്രെയിമിൽ നിന്ന് നോക്കുമ്പം പാർട്ടിക്കിൾ പാർട്ടിക്കിളിന്റെ x ആക്സിലുള്ള മോഷനെയാണ് എന്ത് പറയുന്നത്, dx prime divided by dt prime. This can be represented as ux prime. d by dt of x prime is equal to ux prime. dx by dt is equal to ux minus d by dt of a constant into time is equal to v into dt divided by dt. This one is dt by dt is equal to 1. Therefore, ux prime is equal to ux minus v. This is the velocity transformation equation along the x-axis. Now when we move to the velocity transformation equations along y-axis, we have the equations y prime is equal to y and z prime is equal to z. This is along the y-axis, this is along the z-axis. Now taking derivative with respect to time, we have dy prime divided by dt is equal to dy divided by dt, and dz prime divided by dt is equal to dz divided by dt. Now dy prime by dt is equal to uy prime, which is the velocity observed from the s prime frame along the y-axis. അതായത് എസ് പ്രൈം ഫ്രെയിമിൽ നിന്ന് നോക്കുമ്പോൾ ഇവൻറ്റിൻ്റെ അല്ലെങ്കിൽ പാർട്ടിക്കിളിൻ്റെ വെലോസിറ്റി അലോങ് വൈ ആക്സിസ് നമ്മൾ എന്താണോ കാണുന്നത് അതാണ് യു വൈ പ്രൈം എന്ന് പറയുന്നത്. ദിസ് യു വൈ പ്രൈം ഈസ് ഈക്വൽ ടു യു വൈ, വിച്ച് ഈസ് ദി വെലോസിറ്റി അലോങ് ദി വൈ ആക്സിസ് ഒബ്സർവ്ഡ് ഫ്രം ദി എസ് ഫ്രെയിം. Similarly, dz prime divided by dt is equal to uz prime and dz by dt is equal to uz. So we have got the three velocity transformation equations. We can say that the velocity transformation occurs only along the x-axis. ഏത് ഡയറക്ഷനിലാണോ എസ് പ്രൈം ഫ്രെയിം മൂവ് ചെയ്യുന്നത് ആ ഡയറക്ഷനിൽ മാത്രമേ നമ്മൾ ഒബ്സർവ് ചെയ്യുന്ന വെലോസിറ്റിയിൽ മാറ്റം ഉണ്ടാവുള്ളൂ. മറ്റ് രണ്ട് ഡയറക്ഷനിലും വെലോസിറ്റി നമ്മൾ രണ്ട് ഫ്രെയിമിൽ നോക്കുമ്പോൾ എന്തായിരിക്കും? ദ വെലോസിറ്റീസ് ഒബ്സർവ്ഡ് ഫ്രം ബോത്ത് ദി ഫ്രെയിം വിൽ ബി സെയിം. ദീസ് ആർ ദി ത്രീ വെലോസിറ്റി ട്രാൻസ്ഫോർമേഷൻ ഇക്വേഷൻസ്. Now we are going to talk about the acceleration transformation equation. We have already obtained the velocity transformation equations. To obtain acceleration from velocity, what we have to do is, again you have to take derivative with respect to time. Now take the first equation which gives the velocity along the x-axis. Taking derivative with respect to t on either side, we have d by dt of ux prime is equal to d by dt of ux minus dv by dt. Now we can say that the rate of change of velocity along x direction is the acceleration. Therefore, this term is equal to ax prime, acceleration along the x direction in the s prime frame. This one is equal to ax. Since velocity is a constant, the rate of change of a constant is equal to 0. Therefore, you can write that ax prime is equal to ax. Similarly, these two equations can be written as ay prime is equal to ay and az prime is equal to az. So, these three are the acceleration transformation equations. Now, when you observe in Lorentz transformation, you can see that, not Lorentz transformation, this is Galilean transformation. In Galilean transformation, you can observe that acceleration do not change in both the frames. നമ്മൾ എസ് ഫ്രെയിമിൽ നിന്ന് നോക്കുകയാണെങ്കിലും എസ് പ്രൈം ഫ്രെയിമിൽ നിന്ന് നോക്കുകയാണെങ്കിലും acceleration of the observed particle is same. There is no transformation. So such quantities which remains invariant under Galilean transformation is known as Galilean invariant physical quantity. Invariant physical quantity. So acceleration is a Galilean invariant physical quantity. That means when observed from S prime frame as well as in S frame, we can see that the accelerations are same. Similarly, there are other physical quantities also which remains invariant. For example, uy prime is equal to uy, uz prime is equal to uz. So these velocities are also Galilean invariant physical quantities.